A little bit of a digression, maybe too much information. I usually don't, well, I actually almost never eat breakfast. It gives me a long break from dinner to lunch, and this works fine when I'm just working, reading, doing some computing or whatever else. But this kind of recording podcasts, if I record half a dozen or so before lunch, this actually is a lot of work, so it makes me really hungry. So now I am about 30 minutes from lunch and I'm really starving. So if I fumble something, you should remember that, okay? Structural models and functional models. Human environment systems can be illustrated for focusing on structure or function. Let me use a rather simplified example of a community living next to a river to demonstrate this difference of structural and functional model representation. The people in the community are sustaining their livelihood through farming their plots and selling firewood in the nearby town. They farm corn along the river and get firewood from cutting trees upstream in the catchment area. This way they balance their income with if something unfortunate would happen, let's say agriculture fails or forest burns down and so on. So flood that destroys their harvest could be an example. In this simplified human environment system, floods occur when enough rain falls in the river's catchment area to saturate the ground and overflow the river. The amount of water it takes to saturate the ground depends on the amount of water it takes to saturate the ground depends on the amount and type of vegetation in the catchment area. The illustration of human environment systems that we looked at before is an example of a structural model of this system where its elements can be divided into agents, artifacts, and natural objects that are connected through different types of dependencies as described earlier in the chapter. So let's flip back to 7.4. Oops, maybe I was wrong. It's coming up actually. So here is 7.4. So that's a typical system diagram, and typically you end up having arrowheads one way or both ways to show feedbacks. So here is the river, that's a focal point of our modeling. Catchment area is a component element, rainfall is an element, vegetation, cornfield, and farmers. So example of a structural model of a human environment system. We'll come back and look at functional model in a minute. So this is an example. The illustration of the human environment system in figure 7.4 is an example of a structural model of the system where its elements can be divided into agents, artifacts, and natural objects that are connected through different types of dependencies as described earlier in this chapter. Structural models of human environment systems are static, much like snapshots at specific points in time. However, remembering Stompka's words in chapter 6, we observe reality not as a rigid quasi-object but as a continuous unending stream of events. In other words, human environment systems are by definition never static but continuously transforming through various processes which together with elements and dependencies comprise the core building blocks of any system. To grasp this dynamic nature of human environment systems, we therefore need to complement structural models with functional models. In functional models, the focus is not placed on how different elements cohere, but on patterns of change. Let us go back to the example of the community living next to the river. Farming corn and selling firewood are the sources of livelihood for the people of the community. The more corn they get, the less firewood they need to sell to sustain their livelihood, which is indicated by the negative along the arrow between farming corn and selling firewood in figure 7.5. As I said, that corresponds to a positive or a negative feedback, as we'll see in a minute. A flood reduces the corn harvest, which in turn leads to more sold firewood that generates more cut trees, which reduces the vegetation in the catchment area and increases the flow in the river in the next rainfall, because you have reduced the hydrologic structure and groundwater absorption and the slow flow of the water when you have a lot of trees versus bare soil, or grassland versus tall trees, and so on. This in turn leads to more floods if you destroy the land part or the forest, which is a good barrier to flooding. If nothing is done, the community will see increasing floods that eventually may lead to a collapse of their livelihood source. So corn may become impossible to grow. What you have is a reinforcing feedback loop that is strikingly similar to actual developments along the Artibonite River in Haiti, or in French they would call it Haiti. Okay, so that's our system with its elements, and the people living by making income out of growing corn or cutting trees, and so vegetation, and selling it, right? So if you look at the whoops, where is the feedback? I moved it too far up, didn't I? Let me correct that stupid mistake so that I will put it right here. Am I in the right place? Okay, so let me on the fly also adjust the size of this text here so that I can read it more easily. Coming back then to look at the feedbacks, an example, or dependencies, an example of a functional model of a human environment system. So this is our first model, as we have been discussing modeling or constructing human environment systems. So our system is now represented slightly with links or dependencies. So vegetation in the catchment area affects flow in the river, which also depends on the catchment area. Larger the area, more the water you will collect. So that's the positive effect. Rainfall increases, flow in the river increases, so that's a positive sign. Vegetation in the catchment area increases, lowers the flow in the river because it's holding more water in the soil and in the groundwater. But this can then increase, if flow in the river increases, floods will increase, which will negatively affect the farm, and that will negatively affect selling firewood, in the sense you will sell more firewood if corn is damaged. So tree cutting will go up and vegetation area will go down. So in general, in a feedback loop like this, you take all the negative feedbacks and multiply them. If the net is positive, then it's a positive feedback loop where the initial perturbation will amplify that perturbation somehow, like increased rainfall and selling more firewood, creating a positive feedback here. Negative feedback is a stable system. You can think of the thermostat. You set the thermostat for heating or cooling at a temperature. If the room gets warmer than intended, then the heater will go down. In the case of AC, the AC will kick in, and vice versa, right? So that's now an example of a functional model. This is an example of a structural model. Obviously they are not independent. We are talking about the structure of the human environment system here, and we are looking at its function here. Okay, so am I in the right place? Yeah. So it is important to note that structural and functional models are complementary and equally necessary to construct human environment systems. In other words, it's neither feasible to build any functional model without at least implicitly considering the structure of human environment system in question, nor to address the issues of risk, resilience, and sustainability without at least implicitly considering how changes cascade through the system. So that's the functionality of the system. Considering the many different agents involved in such tasks, it is hopeful to construct human environment systems that include both types of models explicitly, so the structural and the physical, and all the climate models are of course the same, structural and functional, but now they are getting more complicated or sophisticated. For example, older climate models or system models would have prescribed vegetation distribution from satellites or somewhere else, but now you have what is called dynamic vegetation model, where C3 and C4 type of plants respond to warming increased CO2, rainfall changes, and so on, so that the vegetation cover itself changes and feeds back to the energy exchange between land and atmosphere, between the vegetation canopy and the atmosphere, and so on. Okay, so if you don't know what I'm saying, then you can go look up more podcasts of mine under modeling or climate system, introduction to climate science, and so on. So we'll come back and look more specifically at constructing human environment systems based on all the knowledge we have developed so far about elements, the dependencies, structural and functional models, and so on. Okay, so see you in the next podcast.